Now let's look at number 7. And if you notice, this is one which we start out with a trinomial on the top and a trinomial on the bottom. So the very first thing you're going to want to do before we can start finding any of our asymptotes, if it has a hole in the domain, is to factor. So you want to make sure we factor. And we're going to see what we get when we factor the function. Now, if you have x squared minus 4x plus 3, if I do my AC trinomial factoring, 1 times 3, so I need a product of 3, sum of negative 4. Okay, so that's negative 3 and negative 1. Now remember, when you factor, when a is 1 here, there's kind of a shortcut. You can just put it in the two binomials. You don't have to split the middle term. So it's x minus 3 and x minus 1. So this top is going to be x minus 3, x minus 1. The bottom, if I factor that trinomial, x squared plus x minus 12, product negative 12, sum of 1, so that's going to be 4 and negative 3, so that will factor, again you can use the shortcut here because a is 1, so it's x plus 4 and x minus 3. So it's x plus 4, x minus 3. Now, if you notice what happens here is the x minus 3's cancel. That causes a hole where that factor that canceled equals 0. So if I set x minus 3 equal to 0 and solved, the hole will occur, add 3 to both sides at x equals 3. And we're going to have to figure out the actual coordinate of that when we make our table. Okay, so I'm left basically with x minus 1 over x plus 4 for my simplified function. So if I look at my vertical asymptote, that occurs where the denominator is equal to 0. So if I set x plus 4 equal to 0 and subtract 4, x equals negative 4. So at x equals negative 4, right here, there's going to be a vertical asymptote. Horizontal asymptote occurs when you divide the coefficients on x. And if you notice in our simplified function, we have 1 over 1. So if I take 1 divided by 1, I get 1. So it's at y equals 1. So there's a horizontal asymptote at this horizontal line, y equals 1. The domain basically occurs at all reals except our number that makes the denominator 0. Now, we did have something that canceled here, so we have to include that in our exceptions. So basically the exceptions at x equals negative 4, okay, which is the one that's left, the binomial, and at x equals 3, because that made an original denominator 0. So there's all reals except for those two for the domain. So now let's make our table. If we make our table, and our vertical asymptote is at x equals negative 4, I'm going to put VA in my table. So I need to choose some values smaller than that, so negative 5, negative 6, negative 7, and then some numbers bigger, negative 3, negative 2, and negative 1. Okay, and we're looking really at plugging them into the simplified function here of, remember, it was x minus 1 over x minus 4. So if I put negative 5 in there, that would leave me with negative 6 on the top over negative 9, which is going to be it's x plus 4, sorry. So it's negative 6 over negative 5 plus 4, which would be negative 1. So at negative 5, we'd have a 6. Again, we're looking at this table right here. So at negative 5, I'm up here at 6. If I put negative 6 in, negative 6 minus 1 would be negative 7 over negative 6 plus 4, which is negative 2. Negative 7 divided by negative 2 is 7 halves, or 3.5. So at negative 6, we'd be at 3.5. You're just going to have to estimate where that is, which is going to be about right there. And then at negative 7, if I put negative 7 in, negative 7 minus 1 on the top is negative 8. Over negative 7 plus 4 is negative 3, so it's 8 thirds, or about 2.67. So at negative 7, we're up at 2 2/3. So we're about right there. So this is going to kind of look something like this. And again, don't draw it so it crosses either of the asymptotes. And if we look on the other side, I'm looking for this one right now, so if I put negative 3 in, negative 3 minus 1 is negative 4 on the top. Negative 3 plus 4 is 1. So if I take negative 4 divided by 1, I get negative 4. So at negative 3, we're at negative 4, which is going to be about right there. If I put negative 2 in here, negative 2 minus 1 is negative 3. Negative 2 plus 4 is 2. So that's going to be at negative 1.5. Negative 3 over 2. So at negative 2, we're at negative 1.5. If I put negative 1 in, negative 1 minus 1 all over negative 1 plus 4 is going to be negative 2 over 3. So negative 2/3. So negative 0.67 then. So at negative 1, we're at negative 0.67. It's going to be about right there. Okay. Let's go ahead and put in 0 also on that side, see what happens. So at 0, 0 minus 1 is negative 1, 0 plus 4 is 4, so negative 1/4 or negative 0.25. So at 0, we're just below the origin there. Okay, now the one thing you are going to want to put in is we have a hole that occurs at x equals 3, so you do want to substitute 3 in to see exactly where that hole is. So if I put 3 in there, I have 3 minus 1 all over 3 plus 4, so 2/7. So at 3 2/7, and let me make this a little bit, so at 3 2/7, so that would be right here, we have to put an open circle, okay, and so this is going to basically go like this, and then it's going to keep going past that open circle and get close to our horizontal asymptote. And that's what the graph looks like. Very similar to the last one, except for this one does have a hole in it.